All right, hello everyone, and welcome to this webinar for the Introduction to Computer Science Making with the Microbit curriculum. So my name is Jacqueline Russell, and I'm a product manager for MakeCode, which is the coding platform for the Microbit. This is actually the second webinar in our three-part series, and this one is focused on modeling, coaching, and skill building. If you missed the first Getting Started webinar, feel free to watch the recording. We recorded that. It's posted on the event page. And this webinar will also be recorded for later viewing. All right, and so in the meantime, let me go ahead and hand it over to our hosts, Douglas and Mary Kiang, two amazing computer science teachers from California that I've learned a lot from, who are also the authors of this curriculum. So let me hand it over to you, Douglas and Mary, to introduce yourselves.
Thank you, Jacqueline. Really appreciate it. Thanks to Microsoft, and also thanks to Microbit for giving us the opportunity to share a lot of what we do with you. So I'm Douglas Kiang, and I teach upper school computer science here at Menlo School. We're in my classroom, and you can kind of see behind us the beautiful California redwoods. We're located in Atherton, California, which is near San Francisco in the Bay Area. And my partner Mary here can tell you about herself.
Hi, I'm Mary Kiang. I teach 7th and 8th grade computer science and design engineering, so we do a lot of programming and a lot of making and a lot of combining the two. Welcome back to those who were here last week, and if you're here for the first time, glad you made it. So, yeah.
Super glad to have people both old and new joining us. People who have used microbits before, and even if you've never used the microbit at all, we're going to start from the ground up. We first had our webinar number 1 2 weeks ago, and it was basically getting started. And Mary and I wrote a curriculum for middle school, and we kind of went right through how that curriculum is organized. We went through in some detail, showed you what a lot of the different lessons looked like, and then also we talked about how you could go about using this and adapting the curriculum in your classroom, whether you meet once a week for a year, or twice a week for a semester, or 3 times a week for just a trimester. There are lots of different models, and so if you're interested in the details of how you might implement that curriculum, webinar number 1 is available. It was recorded, as is this one, and this one really is focusing on making and coding. And our hope in this webinar, unlike number 1, where it was really us talking a lot, we're hoping to give you some time to actually explore MakeCode on your own. We're grateful that you're here. We know better than any non-teachers. We all know how busy May is, so we appreciate you giving your time to be here. But we've also been to a lot of conferences and we know that as well. We know that just having the excuse to play, I think, is a nice way to learn. And even though, we totally encourage you to log in, use this on your own, experiment on your own, what better time than this webinar that we've kind of set aside for us to be together to have you experiment a little bit as well, because we really do think the best way to learn MakeCode is to actually use it. And same thing with the microbit. And hopefully our curriculum will provide you with some ideas and at least a bit of a map about how you might want to go ahead and explore. So we're going to think about these goals. Our goals really are to play, because we really do believe in a constructivist philosophy that you learn best through play, through trying a lot of different things, through making mistakes and not necessarily getting it right the first time, but just playing and sometimes coming up with some unexpected joys, things that you didn't expect, but it's like, wow, I didn't know you could do that. We want to give you a chance to learn how to use MakeCode by being a student. Really, we're going to give you time to kind of play and learn. We'll also reflect with our teacher hats on, like, what was it like to be a student? And how can I help my students to be successful in their play? How can I, sometimes it sounds funny, sometimes we have to teach our kids how to play. As they get older, sometimes they forget and they start looking for the right answer, or show me the instructions on how to do this. And really, there are no right or wrong answers when you're making with the microbit. And again, we're thrilled to see some of the same people back. Welcome. Good to see you again. Our goal is to help build a supportive community of makers, of microbit fans like us, who just love to make and code. So with that, there are three big things we're going to focus on today. We want to focus on the microbit. We want to talk about MakeCode, which is the software platform that you're going to use to write code for the microbit. And then we want to talk a little bit about curriculum and what that might look like in our classrooms. So first off, let's focus on the microbit itself. And Mary does this great class where she introduces the microbit to the kids. And Mary, maybe you can walk us through a little bit about how do you introduce them to the microbit?
So I talk about programmable devices, like their computer, they're using it to program, but there's other devices as well. Our students have actually, when I get them, they've already had some experience with the Makey, maybe some of them with the Arduino, but wherever they start, I just start out without the laptops out at all and just handing out the microbits themselves. And I give this to them. And before I really say anything about it, before I even show them the current slide that's up, I just do, what do you see? What do you notice? And this really helps you, without the laptop around, without, like I said, we don't usually have that screen up at that time. And it's great because there's no wrong answers to what do you see, what do you notice, and so they really take a good look at it, and they'll be like, oh, there's these little bumps on the front, and then oh, there's these buttons, so we all click the buttons because there's a very satisfying tactile and sound feel to the buttons. We look at the back. There's so much stuff on the back. They wonder about, well, what are these things down here, this gold bar? What are these numbers? So we talk about that. We notice that. We even tilt it in the light. And if you tilt it in light, and for me, I got to take my glasses off, but if you tilt it in the light, they'll like, oh, there's like little lines. And you're like, yeah, what do you think those are? Actually, the circuits that make, connect everything and make it all put together. So it's just a really fun way. I find that it allows them to really look at it and be like, wow, this has a, an antenna on it. It's got a microphone, like things that they might not notice if you just jumped right into having this plugged into the laptop and starting coding. Just letting them have the device in their hand, look it over, really pay attention to it in a very low stakes environment. Yeah, that's how I start. That's literally how I start.
Okay, and then here is sort of a rundown of all of the things that you have on it.
That would be the next thing. Okay, I would show them a slide like this and say, here, yeah, you guys, you found the radio antenna, you found the microphone, the buttons, but hey, guess what? This is also, because they can't tell just by looking at it, that this is also a touch thing, and we're talking about version 2 here. So they really start with just having a chance to explore. And then talking a little bit more about hardware while we're at it, there's so much you can do just with the microbit, but the project that we use often incorporate other things. The basics are the battery pack and the USB cable that allows the microbit to be used away from the laptop. The NeoPixel strips I mentioned before on the last class. I like these from Adafruit because they come perfectly with the 3 alligator clips that are easy to clip right to the microbit, and they work really well. We've used those in projects, and then also little servo motors, which are easy to hook up to the microbit as well. And there's, did you want to go to the next slide? There's just so much that you can add to it, and we'll, as you explore making different things. So do you want to?
Yeah, so before we get to the rest of the accessories, I guess philosophically, you don't need any of this stuff. You don't even need a microbit because MakeCode has a built-in simulator. So you can actually do, I know some after-school teachers who've done pretty successful after-school programs just using MakeCode. But kids will go through that pretty quickly. Once they learn about loops and conditionals and variables, like there's only so much programming that you can do with the output just on that 5x5 LED screen. And so what makes this a full curriculum that really gets kids engaged, even kids who don't see themselves as coders, is realizing that really the microbit is for just making stuff. And so there's lots and lots of things that you can add to it that kind of really make it blossom. And you don't need to buy all of these additional lights and things. Like last week, we showed you examples of making a micropit, where kids actually make an animal out of cardboard and feathers and pipe cleaners, and then the microbit is featured prominently in there, like as the animal's face or as something that reacts to how you tilt the animal. People have made wallets that keep track of how much money are in the wallet, but the wallet you still have to build with duct tape. And so the website and the curriculum have lots of instructions on how to do that. But I guess just that idea that the Microsoft is for making, and if you make this curriculum about more than just coding, but really coding in the service of designing something, that's where it really has some power.
Mm-hmm. Yep.
These are just more examples of things that people have built with these and different kits that you can get. All kinds of stuff here.
Yeah. So I've used a lot of these. Again, the NeoPixel, you can see they come as a ring attachment as well. That you can, some kids. So these are just red lights that you can vary the brightness of, but some kids want to go bigger, full color. So some of those rectangles you see there that have more LEDs on them that show different colors, called zip tiles. We've played around with those. We also have the cute bots you can attach your microbit to. They have little joystick things that you can attach it to. You can use this to radio to this, and so a lot you can add to it, and more coming all the time. But like Doug said, you can just have this and just use a lot of cardboard, tape, all those things that usually just have lying around.
So here are some example projects that you just use the microbit and easy to find household supplies. So you can make a wrist cuff where you kind of put it on your wrist, and you can use it to display things when you tilt your wrist or do other things. These air guitars, so it'll make sounds when you tip the guitar. These light monsters. Here's an example of the wallet that I showed you. So lots of different example projects. So this one here, this is a light monster that reacts to light. So that's kind of neat. Here, this one's a air guitar. So depending on how you make sound and how you, hold on.
Depending on how you tilt it, it makes.
Depending on how you
sounds.
tilt it, it makes sounds. Let me just.
So that one, yeah, well, he's doing that. That one was using the accelerometer that's built in here. And then the previous one was using the fact that the microbit has a light sensor in it, so it can tell if it's dark or if it's light. So you can think of all kinds of different projects you could use that way. And it also, the light monster also had it connected to a servo motor. So it was controlling the servo motor, and it was reacting to light levels. And this one's reacting to how the microbit is tilted and shaken. So using that accelerometer feature. And it goes on over.
Yeah,
That's fine.
So that's fun. I like that one. There's also this one is an example of using the microbit with a NeoPixel strip, and it was created to as a bike safety light.
Yeah, so another great thing about MakeCode, when you attach the NeoPixel strips, you can see it in the simulator. You can actually, so when my students use the NeoPixel strips with their code, I have them test it out in the simulator. And again, it shows the NeoPixel strips and what colors are showing at what times. It even shows them what NeoPixel strip they're addressing, and then they can download it and try it with the real thing. So another great. And same thing for the servo motor. If they attach a servo motor, that shows up in the simulator as well. So that MakeCode simulator is awesome, because I'm like, show it working in the simulator first, then we'll get it working on the actual physical devices.
And the MakeCode project environment allows you to work with blocks. You can also work with JavaScript. And so here's an example where this was actually coded in JavaScript. And you can, in many circumstances, switch right back and forth between them so kids can kind of see how to go from the blocks to the JavaScript. So if you've got some kids who want to actually code with JavaScript, you can definitely do that. Let me go to the next one. So here's an example of making a microbit wrist cuff, and you can find examples of these online on the MakeCode website. They have instructions on how to do this. This is very easy to do with just a cardboard frame and some duct tape, and you can make basically a pretty durable wrist strap. Turns out actually this strategy of using duct tape is very useful because you can make wallets out of it. You can do all kinds of stuff. So, but that's all. This is really physical computing at its best. You can really use the microbit as the center of a whole kind of a maker focused curriculum. But you have the microbit. Now, how do you actually go about coding the thing? And so here's where we talk about the other big tool, which is Microsoft's MakeCode coding environment. And MakeCode is great. You can go to MakeCode.com and you'll see all the different ways that you can use Microsoft MakeCode. They have a great way to do retro style arcade games called Arcade. They've got one, you can code mods for Minecraft. What we're going to be working with today, though, is this one, writing programs for the microbit. So if you have another browser open on your computer, if you just want to go to MakeCode.com, and go ahead and click on Write Programs for the Microbit, and that way you can kind of follow along with us as we go. So go ahead and click that. You can also get there directly by going to
MakeCode.microbit.org.
Yeah, MakeCode.microbit.org will also get you to the same place. But when you click on the microbit section of MakeCode, you're going to end up here. And you can create a new project. Well, first of all, before you create new projects, I always like to scroll through and look at the tutorials. They have lots of really great tutorials that will literally walk you through step by step how to drag the blocks in and do each of these projects. But you can click New Project. Before you go ahead and do much more than that, one of the things that we want to point out, which is super handy, is the idea that now you can sign in. So if you click this Sign In button, you can just sign in with your Microsoft account, and you will be able to then access your same projects on different computers, and this is really useful.
Yeah, because for our students have their own laptops, but when they come to the lab, they're actually working off a laptop cart. So it's so helpful. I always reminding them to sign in, because then after they leave and they have to leave the laptop behind in the laptop cart and they go back and they have their own computer, they can easily just open a browser and access their work. And then it's never lost. They never have to wonder what laptop they left it on. So it's super helpful to have that sign in feature.
Yeah. So again, please go to MakeCode.com, click on Microbit. You don't have to sign in for this. If you do whatever we're going to do now and then you sign in later, it will attach whatever you worked on to your account. So either sign in now or just close that, and then you can go to create a new project, and you will find yourself here. And this is the workspace. So this is where you spend most of your time coding, and then you can see in the upper left-hand corner, there's actually a simulator that shows what your program will look like when it actually runs on a microbit. In the center, you've got these, I call them drawers, but I guess it's a block toolbox. And so each of those drawers has a different color. And so you can access different blocks based on their category. So sometimes I'll ask kids, I'll say, well, go to the variables drawer. Which one is that? Well, it's the red drawer. Or math is the purple drawer. There are also extensions so that you can access some additional extensions for MakeCode if you click on extensions, and then you can add those. And this really is analogous to importing libraries. So if kids are working in Python, and if they've ever gone and said, import this library or sharp include a library, that's essentially what we're doing here. And this is why for me in the high school, I love starting with MakeCode because it really gets kids ready to start programming in other languages, because all they need to do is say, well, you remember in 8th grade when you went to extensions and you added in the extensions to the NeoPixel strips, or for other things that gave you these additional capabilities, you're adding a library. And so a lot of that vocabulary comes back, and it helps kids learn more advanced languages. Towards the bottom, you'll see options for downloading your program to a microbit. You can download it to a file and then drag the file onto the microbit, or there are ways to connect wirelessly as well.
Well, it's only the wire, but yeah. Okay. Yep.
So with that, that's MakeCode. We're going to do a little bit of hands-on stuff with MakeCode in a second. But let's talk a little bit about curriculum. And actually, I'd like to go a little bit higher level. I want you to think about, when we talk about curriculum, I want you to think about a time when you were so engrossed in something that the time just like slipped away. Like before you knew it, you looked up at the clock and you're like, oh my gosh, 2 hours have gone by. Couldn't even realize where it went. What was that for you? Yeah, for me, it's gaming. Sometimes I'll be playing a video game, and before I look up, I'll realize, oh my gosh, all this time has gone by. I didn't even realize it. What does that for you, Mary?
Probably reading, especially getting into a really good story. I could read for hours, or working in the garden, or solving puzzles. I love puzzles of all kinds, so I'll just dive into puzzles, and I could spend hours doing that. I lose track of time that way. Yeah.
So I'd love to ask you to click on the chat button in the bottom. And what is something that does this for you? What's some activity that you do that you just completely lose track of yourself while you're doing that activity? Think about something that does that for you, and please put that in chat right now. Some people have said knitting. I had someone who was a competitive swimmer. She said swimming does that. What's something that you do where you completely lose track of time?
In a pleasurable way.
For me, it's leading one of these webinars. Where does the time go? I'm going to move on. I want to hear what you have to say.
There's a few in the chat.
Oh, there are. Okay, great.
Yeah.
Oh,
so we've got, Craig says playing the piano.
Oh, great. Okay.
Moreland says repairing and programming computers, which is amazing.
Love it.
Devona says being on social media.
Ah, yeah.
Tiana says 3D printing.
Nice.
Connie says cycling. Marie says beadwork.
Nice.
Arnold says my fur babies. And Carlotta says reading.
Okay, so
I put weeding. So it's springtime in Seattle, and so my garden is out of control. So.
Oh gosh, great. So all of these things that you're describing, thank you, by the way. And as you think of others, go ahead and post it. My chat wasn't refreshing for some reason, but now it is. This puts you in a state that we call flow. And so there was a educational psychologist named Mihai Csikszentmihalyi who wrote a book on flow. And this idea of flow, it's this idea that you completely lose track of time because you're so enraptured in what it is that you're doing. And it happens when the task that you are doing is kind of perfectly matched to your ability. In other words, it's not too easy, it's not too hard. Sometimes we call it working at the point of struggle. In other words, at the place where you're getting stuck, but you have the resources and the support to figure it out and move beyond it, but it's not so easy you're getting it right the first time. And that's actually a perfect description of coding when coding is working well. We're putting students in this state of flow, and it's also a place where optimal learning takes place.
Yeah. So this image is actually one of my students. He was coding something for his fairgrounds project, and he was just, you can see he's like zeroed in on the code, trying to figure out what works. I think he was looking for a bug, but he's just, we actually cropped the background out. The background was a very busy background. Other people around him were working and building things, and because there's a physical component to that project, and he was just so laser focused in. I just sort of had to capture that. And it's so funny, like flow, literally today, one of my students described flow without knowing he was describing flow. We were doing an activity and he was like, that was just perfect. And I'm like, what made it perfect? And he goes, it was just like, it was hard, but not too hard. And I knew I could do it, but it wasn't easy. And I'm thinking to myself, he's describing flow, and he was just totally immersed in it. So the kids, even if they don't have the word for it, they know it. They know it when it's happening to them. So, and it's a wonderful place to be.
Yep. I had a buddy who likes to do backcountry hiking, and he kind of loses track of time there. And he said having a GPS map has kind of helped me to, before I would only go places that I knew, but now I can go off the beaten path. I can go off the trail a little bit and explore more. And that's a case where technology kind of enables that. And I think MakeCode functions in the same way because it allows kids to explore and to try things out in kind of a lower risk environment. And I think that there's something there. It makes me think of this story that I heard once about these soldiers who had gotten lost in the Swiss Alps. It was a military patrol. They got caught in a blizzard, and they were lost, and they were frightened. They didn't know their way out. But then one of them found a map in his pocket, and so they consulted the map, and then they built a shelter. They planned their route, and then they kind of waited out the storm. And so the storm clears a few days later. They're able to hike their way out, and they made their way back to base camp. And their commanding officer was astonished to see them, but he was relieved to find out that they had survived. And he asked them, well, how did you manage to find their way out? And they said, well, we had a map, and the map saved our lives. And they pulled the map out. And what they were astonished to find out was that the map was actually a map of the Pyrenees Mountains in France. It wasn't a map of the Swiss Alps at all. But the map saved their lives. It truly did. And I always find that an interesting story, right? Because what did the map really do? The map actually gave them confidence, right? The map gave them an impetus to get moving, gave them some inspiration. And sometimes direction is more important than the details, right? The map rekindled their awareness of those details and made them aware of what was around them. And I think in many ways, that's what a good curriculum does. A good curriculum gives kids a framework within which they can improvise. And it allows them the freedom to get lost without getting too lost, right? If you don't have a map, you don't feel free to explore. But a good map that gives you a little bit of ability to get stuck and then get unstuck, well, that's what computer science is all about. Right, that's what we're trying to get kids to do. We want them to try things, to not have it work right the first time, but then to figure it out. And giving kids a curriculum, giving them a map, a general framework to follow, but then giving them some flexibility within that framework, I think that's the key. And that's really what we tried to do with Making with microbit, which is our curriculum that we put together. So just really briefly, Making with microbit is 12 units. It focuses on very specific concepts and skills. It's mapped to computer science standards. Depending on how often you meet, it could take you anywhere from a semester to a year, depending on how you go about spending time with it. But it's about probably 16 to 27 hours total of work. And so with another 22, 25 hours of instruction. There are 3 lessons per unit. There's 12 units. Lesson A is generally an unplugged activity. Lesson B is more of a birdhouse activity or a guided activity, which we'll give you an example of in a few minutes. And then lesson C is that independent project, that place where we've given them some skills. They're going to go out, they're going to get lost a little bit, they're going to get stuck, but they will find their way out because you've given them some good support and some good guidance along the way. So this curriculum is free. You can find it at this URL, aka.ms/introCSEDU. And you'll want to have 2 things. in front of you for the next bit. You'll want to have MakeCode available in a browser, and then maybe have the curriculum so you can go through the curriculum as well as we go. So there's a lesson structure in the curriculum. And again, lesson A is your unplugged activity. Lesson B, you're going to spend maybe 1 or 2 classes on doing a birdhouse activity. Lesson C is generally the independent project or the application of it. We're going to really focus in on the birdhouse activity. Last time, Mary walked you through a lesson A, which is robot artist, so learning how to be precise in giving instructions. Today, we're going to do scorekeeper, which is a birdhouse activity. And 2 weeks from now, in webinar number 3, we're really going to focus on independent projects. So we'll give you lots of examples of independent projects, and Mary will kind of give you some examples of an independent project she does with her students. So lesson A, for the variables unit, which is what we're looking at, is really having kids play rock, paper, scissors together, and it's having them keep score. Now, we're not going to do lesson A in this webinar, but just to kind of show you how we would set it up, we would go to the Microsoft PowerPoint presentations that are included in the curriculum. And these are excerpts from that slide deck, so variables in daily life. So if you've gone to that website, aka.ms/intro-cs-edu, you can get all of these PowerPoints there. And it basically goes over what are we going to learn in lesson A. In this unplugged activity, well, we're learning the difference between a variable and a constant, and we're going to learn 5 different types of variables. And we explain the idea, that constants are values that don't change throughout the life of the program, but variables are things that are going to vary or that are going to change. We talk about different kinds of variables, right? Things that change, things that don't. The city names, for example, New York City, Washington, D.C., those could be constants. But the low temperature, the high temperature, those are going to be variables. We start talking about different types of variables, so numbers, strings, booleans, a sprite, which is really helpful on the microbit. You can refer to locations on the screen as a sprite. And then we talk about arrays.
And again, depending on where your children are, where your particular students are, you would vary that. If they're more advanced, definitely, go through arrays, whereas if they're younger or just starting out, you might save arrays and things for a later time and just focus on those first few.
So Mary and I have gone through lesson A already, and we've kind of done rock, paper, scissors, and we kept track of how many wins we had and how many times we tied. And as we wrote this down, we would then talk to students and say, well, on your score sheet, what would be a constant? What doesn't change? And then what kinds of things would be variables, and try to identify those. And so that's all for lesson A. We want to learn the difference between constants and variables. We want to do that activity of rock, paper, scissors, and then keep track on a piece of paper. And then our lesson B, the birdhouse activity, is basically to make a scorekeeper using the microbit. Or in this case, using the simulated microbit on MakeCode.com, which you can totally do. And these are all the things that you're going to need to do for lesson B. You're going to need to be able to code with string and number variables, give the variables some good names, use some math operations with the variables. And these are sort of the pseudocode steps of what you're going to need to do to code that scorekeeper. So creating and naming your variables, initializing each of these variables, and then updating their value, and then adding some feedback, in other words, some output on the program to kind of show what the scores are for the different number of Mary's wins, my wins, and then show the final values. So the way that you would do that, and I would basically demonstrate this in MakeCode, you would go to the drawer called variables and select the Make Variable button. And then here's where you're allowed to basically name it whatever you want to name it. And here's where I usually talk with students that, they're good names and bad names. Any name will work, but calling it N or num1 or num2, those are not good variable names because they don't explain what the variable is actually intended to represent. And so in this case, we don't have to pay by the letter here, so it's okay to have a long variable name. It's okay. Be descriptive and say what it is. There is a block called onStart, which automatically runs when the program starts. And here's where we would initialize. And this is where we're starting to introduce these important vocabulary terms. Initialize gives it an initial value. There's a pull-down menu that you can use to kind of choose which variable. If you've got more than one variable declared, you'll see it in the pull-down menu. And you can start all of them at 0. And so all of these instructions are in this slide deck, yeah. And then here's where you can drag out the 3 button press. So anyway, all of these instructions are here. It's also in the write-up as well. And so I'm just going to whiz through the rest of these. If you go to this URL, so tinyurl.com/ISTEbirdhouse, all of those instructions that I just went through are there. And I'd like you to take the next 10 minutes and create a scorekeeper in MakeCode. So we're going to pause for about 10 minutes, and I want to give you a chance to go through here and work through these, okay? And again, I think you get the most out of it. I get the most out of it anyway when I'm actually doing something. So try it out. It's okay if you don't finish the entire thing, but at least try dragging out some of the blocks and get the hang of it. And then we will see you back here in 10 minutes when we're going to go over microbit classroom, and I'll show you what it looks like to actually set that up. Okay, so we're going to continue now. 10 minutes is not really enough time to do the lesson B. You know, you probably would give kids the whole period to work on that and circulate the classroom and help people. We would probably then have a discussion about, well, where did you get stuck and how did you get unstuck? And that's always a great thing to do when you're a teacher going through these lessons. We would highly recommend that you do the lesson B before you have the kids do it, just like you did here. And just try to remember, were there things that seemed confusing or where you got stuck? Because, you know, if you got stuck on it, other kids probably will get stuck there too. And one of the things about computer science is, for students, when they get stuck, they think they're the only ones that don't get it. And I don't know why it is about coding or computer science where that happens. I haven't seen it to that extent in other subjects.
Except for math. It happens.
Maybe, yeah. But we're constantly trying to cure kids of that notion that, you know, if you got stuck, you're very smart and you belong in this class. And if you got stuck, guaranteed other people got stuck too. So same thing holds true for us as teachers. So with your student hat on, try each of these activities out before you present it to students, and then you can help support and provide scaffolding where they might get stuck. Okay, so how do you go about setting this up in a classroom? Every kid's got a laptop. They're all working on MakeCode. I like to circulate around and take a look at what kids are doing, and that's a good way to do it. But we also want to show you Microbit Classroom. And so Microbit Classroom is offered by microbit.org, and it is just a great way to start a lot of these projects. And so I'll give you a quick little demo if I wanted to do, so after Scorekeeper, there actually is a unit where we actually have kids coding rock, paper, scissors. So you can actually shake the microbit and then it'll randomly choose scissors or paper or rock. So that it's kind of a fun activity. And how would you go about working on that with kids? So let me go ahead and show you. If you go to Microbit Classroom and you go to Browse Projects, you can actually go through and you can actually see all of these different projects that you can try out. And you can add these to any classroom session.
And they're also ranked as to like whether it's a beginner kind of code or a more advanced kind of code. So you can actually, for yourself or for your students, you can sort of guide them towards the level that's appropriate for them.
So I found rock, paper, scissors, and I'm going to choose Open in Classroom, and it's just going to open it up in Microbit Classroom. And you can choose what to give kids as starter code, and then you can also have example code of what the solution might be. So I'm going to click Edit. And so for the starter code, I want to give them some examples, some place to start. And so one thing we like to do is we like to pull in some of the blocks that we know kids are going to need. You can also leave a comment, and you can write in on the comment, basically give kids instructions, this is what needs to go here. And so in some way, you can provide some pseudocode to the kids, and then they're still going to need to go and grab the right blocks and pull the blocks out to put them in the right order. But you can give kids starter code with some of the blocks there with comments that explain what needs to go here. And then you can send that starter code out to all the
It's
kids.
kind of like pulling all the ingredients of a recipe out, and some people, it depends on how much guidance you want to give them. Some people just pull the ingredients out and then the kids have to put them together. In other cases, you can put some more of it together yourself, again, depending on the level of your students. And then, like you said, you can add the comments that they can read. And you can close up, you can minimize the comments, or once they're done, they can click the trash can on the comments, but it's there, again, sort of as a map, kind of helping them out along the way. And then Microbit Classroom is real game changer. There's all this wonderful stuff you can do in the Microbit, but when you have a class of like 20 something students or more, it's like, how am I going to manage all these different projects? Well, Microsoft Classroom is the way to keep track of all of it. And go ahead.
So I've just published in this example. This is just the example. We're not going to do rock paper scissors, but everything has a join code, and so. For what we would do as a follow-up to Scorekeeper, we had you do Scorekeeper. We probably would have given you a whole period to do it. A lesson C for this might be create a project that does something cool that uses at least 3 variables and outputs that information in some way. And that would be the follow-up project. We only have 10 minutes, but I wanted to give you a sense of where would we go after the Scorekeeper. And so what I've just done is I've created a this is a session in Microbit Classroom. And so if you go to microbit.org/join, the name of the classroom is Hot Indigo Castle 94, and that's the password. And so if you go to this now, you can join this classroom. Now I understand from microbit.org that the practical limit in a classroom is 30. And I think I think we have enough people here. We're not going to go over that max. You can go over 30. It just slows down a bit. So I think we'll be fine. But go ahead and try that. And then I'm going to actually change to, so you can kind of see what I see as a teacher. And we'll go to this live. Yep. This is the join details. Yep. And we'll just let's get a few people in here.
Thank you, Marie. Thank you, Jacqueline.
And I will also go there on mine. Let's see, Microbit.
Linus is there. Mumforder is there. Carnell.
All right, so the weather is hot, but I want them to see if people, because unless
I see.
You're not.
Yeah, how it goes. Yeah. Three IQ.
IQ or 1Q?
Oh, 1Q. Yeah.
And MMR. All right. Just so you can see, if you haven't joined, just so you can see what it looks like as a student, I'm joining on another browser on my computer. And so you'll notice you can raise your hand. And this comes up with, this is the code for Scorekeeper. So if you didn't finish, this is sort of where we're hoping you would begin at the start of the next session. So hopefully you would have code that you can then work with. But what I can also do is I can send code to everyone in the class. So I can make some edits here, and if I go to send code, this will then push the code to everybody here, and then you'll get a. This is actually the same starter code, but let me just choose. I'll choose Douglas and send code individually to Douglas. And I'll get the option to overwrite my code. So I can either accept the code from the teacher or I can keep my existing code. But often what I'll tell kids, I might have a section of code that I want everyone to start with as another starter project. And so I'll ask kids to accept the code when I send it to them. I'll just send it to everybody and then they'll replace what they're working with. So I'll say you have 5 minutes to kind of do some changes, and then we're going to start with something new. And so you can then overwrite this, and then it'll just accept that. Now, again, going back to the original prompt, for me, I've asked the kids to do something cool. Use at least 3 variables and output information in some way. And what I can do in Microbit Classroom is I can take a look at Douglas's code, and I can say, hey, Douglas, I can see that you're using variables in this way. That's really cool. And then if I'm projecting this, I can show this in the classroom to kids so that they can see it. Or, of course, you can always use Microbit Classroom in an online environment like we're doing here. But I can go through and I can look at other people's code as well. And I can see how they're, so as they're making changes, it will reflect in real time here. So I can go through and I can see what everybody is doing here. Right. So yeah, and again, if someone erases their starter code, I can always go and project it. So or replace it and send them new starter code.
Jacqueline's erasing things.
Yep. Yeah.
So if you were checking in on Jacqueline, you could see, you got your on start there, but it looks like you're starting from scratch for the rest of it.
Right.
So.
And I might not, actually, most of the time I probably wouldn't project it the way I'm doing here.
Right.
I would just use it as a way to kind of check in with kids to kind of see where they are.
You're the one looking at it. We're showing you now because Jacqueline's a good sport. And yeah. Well, yeah, if you were looking at it as a teacher, you're just going to pop in on your laptop. You can see where the students are, what they're doing, what they need help with. If they accidentally, because this happens, they accidentally erase some block of code and then they can't remember what that was, but you can see that. And you can also leave them comments too. So
now the really neat thing about this is at the end of a session, at the end of class, I can save the entire session as a file, and it saves it as an HTML file. I can just store it on my desktop, and the next time I go back in, I can basically load a saved session, and everybody's work will come back the way that it was. So it will save everybody's work. So if you're ever like me and you're in flow while you're teaching and you look up and it's like, oh my gosh, I've run out of time. Class is over. I can hit save, and then the next time they come back in, I can start it up again, push everybody's code back out to them, and then restart that way. So again, we just wanted to show you. In fact, I'll do that now. I'll go ahead and save this as a file. And then I'm going to end the session. All right. And then we'll be back to where, so that's just a basic, very basic example of what you can do with Microbit Classroom. But again, I think you learn best through play. I'd encourage you to try it out, set up a sample session. You can be a student on the same computer, just like I did, by using a different browser. Notice that you probably also had the option to save your own code as well.
But Microbit Classroom is just so useful for staying organized, keeping the kids organized, being able to do those most valuable check-ins when you can't quite, get to everybody as quickly as they want you to, or if they're like, can you look at my code? And you can see their code without having to be leaning right over them. You can see their code on your screen.
Mm-hmm. Yep, absolutely. So Yeah, with that, we were so much in flow. I think we've run out of time. But that's what we have for today. What we do want to do is kind of encourage you to come back in 2 weeks. We're doing another webinar, and this one really is going to be focusing in on that Project C, on independent projects, and what kids can do when you give them the opportunity to get lost with a map and really explore and learn some new things on their own. So if you want to register for this, I'm going to paste the registration link directly in the chat. There's also that bit.ly link is a shortened version of that same thing. And that's going to be May 28th at 3 p.m. But I hope that this has been helpful. We wanted to give you an introduction to how we introduce the microbit in terms of the hardware, get you playing around with MakeCode a bit, and then
Microsoft,
finally show you
microbit
classroom. Yeah. So if you have any questions, we'll stick around for a few minutes. We'd love to have you post questions in chat, but otherwise, we really hope you got something useful out of this session, and we hope to see you again in 2 weeks. Thank you.
Thank you.
Thanks everyone for joining, and thank you Douglas and Mary for a wonderful webinar number 2. Looking forward to the next one. So for folks who had to sort of leave and then come back, this session is recorded. I will be sending out a mail to everyone who is registered with the recording, so you're free to go back and watch it. And I also sent in chat a link for where you can register for the next webinar, as well as some other MakeCode training this summer. And I think Douglas also put in the link for the direct webinar event page. So thank you all so much for dialing in. Really appreciate your time, and hope to see you in a couple weeks.
Have fun playing. Find your flow.
Thanks all.
You.
Bye.
Bye, everybody.